Okay, good afternoon, class. So today we're looking at, okay, firstly, you guys had homework. The homework was exercise 3, I think, no? 2. Haven't we completed 2? Not everything. What haven't we done in exercise 2? What haven't we done in exercise 2? The even numbers. Sorry? For exercise 2. Isn't that exercise 3? Now who says exercise 2? Sorry? What did you say about 2? What must be done out of 2? Just check what wasn't completed in 2. Let's try never to leave questions unanswered. No? So it might be that that is the question that comes in. You understand? Thank you, Sherry. Anything? Come, exercise 2. Nothing. Okay, I thought as much. There was one example in exercise 3, for exercise 3 that we needed to do, which was number 7, correct? And this is the one you're talking about, no? Nice. And which page is this on? Page 96. Let's pull him down. The maniki, Sukamaso. Okay. Mzikelo 7, ne? Example 7, Mzikelo. That was example, ne? Kinda. Right. People, in example 7, we are to prove that cos of 3x equals 4 cos cube x minus 3 cos x. People, what is this to us? An identity. Not so. So can I take things over the equal sign and so on? No. Now expansion is always easier than factorize, than reduction. Not so. If we have a choice of multiplying numbers out compared to factorizing it, to multiply it's easier. Not so. To expand is much easier than to reduce. Okay, to multiply or products is easier than factorization. But some of you are going to say everything is easy. No? But not to all of us. Okay, so what we do is we choose the easier way out. The easier way, definitely the easier way of working this left hand, the right hand side of the equal sign, and make it equal to the left hand side. I've seen people do that already. They always choose a more other way and then manage to get it. As I said, the easier way, definitely. Okay? But we're not here in the business of making things difficult. No? If you can do it, no problem. It's fine. We can mark it. Okay? But from the 2, to expand 3x into 4x cube x, and 4 cos cube x minus 3 cos x is going to be much easier than reducing the left hand side to the right hand side. Does it make sense? Right. So let's look at this here quickly. Remember from the last lesson when I had to run, we had cos of 2 alpha. Cos 2 alpha could be written as 1 of 3, as 2 cos squared alpha minus 1, 1 minus 2 sine squared alpha, and cos squared alpha minus sine squared alpha. Then we also got the other rule that says, with that identity, which is 2 sine 2 alpha can be written as 2 sine alpha cos alpha. Not so? So, coming back to what we have here, they ask you to prove that cos 3x is equal to that. So, of course, the left hand side is going to be more complex and easy to work with. So, it's going to be the left hand side equals 3 cos x can be written as what? Cos 2x plus x. Why do I write it like it? So that I can use. You okay? Yes, you're shaking, sir? Are you getting cold? What, are you okay? Yeah? Give me a shock here. People, cos alpha plus beta can be written as cos, opposite sine, sine. I think that's behind the calculator at this point. But I'm sure you know the identity at this point. Okay. You all agree with that? So if you're going to use a cos expansion here, what would it be? It will simply be cos 2x cos x minus sine 2x sine x. Not so? They have used that cos expansion. Okay. Now what? We always keep our eye on this part of the equal sign. Okay. What do we have here? On that side of the equal sign, what do we have? We only have causes. Not so? Which means to say I must get rid of the sign somehow or other. Not so? We come now back to this one. That is the one we always do last. But I know some of you can see it already. Which one of the three that would be? However, this Mickey Mouse here is nothing to do with it. Can you see that? So, sine 2x can be written as what? Can be written as 2 sine alpha, 2 sine 2 alpha can be written as 2 sine alpha cos alpha. Not so? So let's do that thing. So we're going to have here negative 2 sine x cos x times sine x. Not so? The reason why I keep this cos of 2x and do that normally second is because cos of 2x has one of 3 solutions it could have been. Or one of 3 identities you could have used. Okay, can be used as what? 2 cos squared alpha minus 1, yes? Can be written as that one. 2 cos squared alpha minus 1. Or 1 minus 2 sine squared alpha. Or cos squared alpha minus sine squared alpha. It can be any one of those 3. Not so? They say, okay, hang on. Which one do you think are we going to change it to? Which one are we going to choose of those 3? Will it be 2 cos squared alpha minus 1? Why that one, people? Why this one? Because of what we have here. You see that? If I had signs there, if this was sine here, 4 sine cube x, whatever, then I would have definitely have gone with this one. Why? Because there are signs. If it was cos squares and sine squares, or cos cubes and sine cubes, then I would have of course go with that one. So there's causes and sines. You guys understand? But since what we're working towards deals with cos only, that is why I'm going to choose the one dealing with cos. Does it make sense? Okay. So let's replace that quickly. It's going to become 2 cos squared x minus 1 times cos x. Okay. Now what? Now what can be done? Get rid of the brackets. Yes, nice. What can be done on the side of the negative side? When you're in your second term. 2 sine x cos x times sine x can be written as what? negative 2 sine squared x cos x. Multiply the story in here quickly. So what do we get? Hi. Hi.
Can
How is it?
Oh, good, thanks, man.
Good, good.
Can I give
First send it
this
out. When you gonna come to our class?
No.
Aren't you guys working in maths now?
Yes, we are.
Oh, okay. So what do we get if we multiply this in? Okay, everybody must look here now. Everybody?
Thank you, sir.
With pleasure. Multiply, what do we get? 2 cos cube x minus cos x. Is that what we have there? No. So what is still the issue here? Sorry? Sine squared x, that's the issue. So that can be changed into what? Sorry? Sine squared x can be written as what? 1 minus cos squared x. So you write that in there and you multiply it out. So what do we get? 1 minus cos squared. Now what do we do? We get rid of the bracket, multiply, not so. So we get 2 cos cube x minus cos x minus 2 cos x plus 2 cos cube x. Now what do we do? Add like terms. So that one and that one is like terms. So it's going to be 4 cos cube x. That one and that one is like terms, which is negative 3 cos, which is equal to the right hand side. Guys understand? So do it again. No. Okay. Nice. Any confusion here? No? We can delete this. Now we're looking at example 3 on page 98. Okay, you guys have done the first column or the odd numbers only. Not so. So I'm going to do each and every sum here. Show you my commitment to the tricks, no? Don't be caught off guard when you write your trig final exam or in your control test. Okay. Let's do this. First question says, use the double. So firstly, we know that sine 2 alpha is equal to 2 sine alpha cos alpha. Then cos 2 alpha can be written as 1 of 3. It's going to be 2 cos squared alpha minus 1, cos squared alpha minus sine squared alpha, and 1 minus 2 sine squared alpha. Okay. Very important to be familiar with those identities. So you see that sine for a can be written as sine 2 times 2a. You all agree with that? Which now can be written as your alpha is now 2a. So it's going to be 2 sine 2a cos 2a. Am I going to take it further? No, because I don't want it in terms of 2. Does it make sense? Let's look at the next one. Cos 6a can be written as what? Cos 2 times 3a. Now I can choose any one of the 3a. Not so. I can just see, could it be written as 2 cos 3a squared minus 1, or cos squared 3a minus sine squared 3a, or 1 minus 2 sine squared 3a. Either one of that would have given you the correct answer that you can put. Okay, let's go to 1.5. So here you see you got sine of a only. So your answer must contain sines and the angle must be in terms of a. Okay. So this can be written as what firstly? Sine of what? 2 times 2a. Which now in turn is equal to what? 2 sine, the alpha angle is now 2a. 2 sine 2a cos 2a. Is that what they want? No. Go further. You see here, this can be written as 2 times 2 sine a cos a times, which one of the three you think we're going to choose for cos of 2a? You all agree it can be any one of those three, no, for cos. But which one do you think we're going to choose here? 1 minus sine. There's 1 minus 2 sine squared a. Why that one? Because they're talking about sine only. Okay. But what is the problem still there? What is still the issue here? It's cos here. That's the issue. But cos theta can be written as what? In terms of sine. Cos is equal to sine of what? 90. You see sine of 90 minus a is cos a. Not so? So cos a is sine 90 minus a. So there we go. 2 times 2 is 4. Sine a times sine 90 minus a times 1 minus 2 sine squared a. There we go. Nice question. Do it again.
Yes, sir.
Okay. So the question is to write sine 4a in terms of sine of a. Okay? So this can be written as sine 2 into 2a. It's your sine expansion, which is sine 2 alpha is equal to 2 sine alpha cos alpha. Your alpha angle is now 2a, so there goes 2a and 2a. Okay? So that's going to be 2 sine 2a cos 2. So the next one is going to be 2. Now sine 2a cos, sine 2a can be written as 2 sine a cos a. Cos of 2a can be written as one of these three. Since they want sine only, I'm going to use the last one, which is 1 minus 2 sine squared a. As you can see, they wanted cos only, sine only, so you replace the cos. And the cos can be replaced with this co-function, which is sine 90 minus a. So that's going to give us 4 sine a sine 90 minus a into 1 minus 2 sine squared. Okay? (1.7), what do you notice here? You should see sine alpha, 2 sine alpha cos alpha. You will see that. Sine alpha cos alpha. So 2 sine alpha cos alpha is equal to sine 2 alpha. So it's going to be sine 2 alpha. But what's my alpha angle here? Of x. You see that, people? And what is 2 times of 1? So this is going to be, there we got it. Okay. Any confusion here? No? (1.9) (1.9). Do you see that can be written as 2 sine alpha cos alpha? You will see that. That is 2 sine alpha cos alpha. So, for inside the bracket, that can be written as sine 2 times alpha. Not so? Now this 2 here, on the outside, is this 2 in front. You all agree with that? And what's my alpha angle here? Sorry? 3a. So that would simply be 2 sine 2 times 3a? 6a. 2 sine 6a. Okay? Any confusion there? You all understand? Okay? Let's carry on with our lives. Right, question 2.1. Write each expression as a single angle and evaluate if possible. What do you see here? You should be seeing 2 sine alpha cos alpha. You all see that? 2 sine alpha cos alpha can be written as what? Sine 2 alpha. And what's your alpha angle here? 30 degrees. So it can be written as what? Sine of 60 degrees. And sine of 60 is what? Root 3 over. Any confusion there? Huh? 2.3. One minus 2 sine squared alpha. What does this remind you? Cos 2 alpha. Not so. That one is this one here. There's a 30. Can you all see that? So it's going to be cos 2 alpha. And what's your alpha angle here? 30. 2 times 30 is 60. Cos of 60 is 1, 2, root 3. Cos of 60. The choice of hypotenuse is 1 over 2. Okay? Any confusion there? No? .5. Is that the case of 2 sine alpha cos alpha? You know, you can't do that. Why? Because the angles are different. So what am I going to do here? Change it, reduce it to the same angle. So it's going to be 2 sine. What will this be? 180 minus 30 times sine. So in other words, I must pick up a 30-degree angle here. Give me a chance. Okay, she's correct, 270 plus 30. Okay. So 180 minus, which quadrant is that in? All stations to claim. Which quadrant is that in? 2. We sign positive or negative? Positive. So it's going to be 2 sine 30 degrees times 270 plus, which quadrant is that in? 270 plus 4. Is sine positive or negative? Negative. Sine cos, yes, absolutely cos. You don't even give me a chance to make a mistake. You are right. Don't give me a chance to make a mistake. I shouldn't be making a mistake. No? So what do you notice now? That is going to be negative 2 sine 30 cos 30. Is that not 2 sine alpha cos alpha? Sorry? Yes? So this negative on the outside is that negative. Okay? So 2 cos alpha, 2 sine alpha cos alpha can be written as sine 2 times alpha. And what's my alpha angle here? 30. Which is negative sine of 60. Sine of 60 is negative root 3 over 2. Okay. Any confusion there? What do you notice here? What can happen on top? Sorry? We got the common factor? Common factor of 4. What are we left with? 1 minus 2 sine squared alpha, which in this case is 15, over. So what happens now? 4 is cancelled. So it's 1 minus 2. So you're left with 1 minus 2 sine squared alpha. But what does this remind you of? Cos 2 alpha. Not so. So it's going to become cos 2 times 15. What is cos of 15? 2 times 15? 13. So that takes you to the special triangle. So it's 1, 2, 3. So cos of 30? The adjacent over hypotenuse, so it's root 3. Okay. This gets sweeter and sweeter, no? Nice, this stuff. Huh? Yes, okay, nice. How can it not be nice? So easy. We do it again today and you'll see how easy it is. Alright. Let's pull this Mickey Mouse down here. Right. Let's do it again. Right. So here we are told in number 3, simplify each expression as a single trigonometric ratio in x or 2x. Right, so what's happening here? What is cos squared x minus sine squared x? Cos squared x minus sine squared x. That? And that's the same. Not so? So cos squared x minus sine squared x is the same as cos 2. What is cos squared x plus sine squared x? 1. That's simply going to be cos squared x. Sorry, cos 2x, not cos squared x. Cos 2x. Okay. You look at the next one. What do you think can be done here? What do you think can be done here? Binomial squared, yes? Square the first term. So that's going to give you cos squared x. Otherwise, if you don't know that, you can do it like this. Cos x plus sine x squared can be written as cos x plus sine x times cos x plus sine x. And then you multiply this whole story out. Okay, you can do it like that. Or, if you know the binomial square rule, simple. Square the first term. That times 2 is going to be plus 2 cos x sine x. Last term square is going to be plus sine squared x minus 1. So what is cos squared x plus sine squared x? Sorry? 1. So it's 1 plus 2 sine x cos x. Minus 1. So what can happen now? What can happen now? 1 and minus 1 cancel. So we're left with 2 sine x cos x. And 2 sine x cos x is also what? Sine. Okay. Any issues here? No? you're having problems with these people, you must watch this video again. Okay, do it again and again and again. Okay, until you are comfortable with it before you do the even numbers for tomorrow. Okay. People, what can happen here? Many things you say. Many things can happen. What are amongst the things that can happen here? Tan, yes, tan changes to sine of a cos, yes. What else can happen? Sine 2x can be written as sine 2x 2 sine x cos x. So tan can be written as sine x over cos x. You don't change this until you're sure about what's happening. So what can happen now? Wat kan nou gebeur? Sorry? What cancels? Cos x, nice. Cos x cancels cos x, so what do we left with? 2 sine x times sine x times sine x. And what is 2 sine x times sine x? Sine? Sine squared x plus sine x. Not so? And what is 2 sine squared x plus sine squared x? Sorry? So 3 sine squared. Okay. Could you guys have helped each other on Friday? When I left? And Mr. Engel? Did you say thank you for looking after you guys? Yes, thank you. Right? So what's going to happen here? What is going to happen in 3.7? Yeah, let's pick up the pace. Otherwise, they're going to finish that one. 3.7, what's going to happen here? Change tan, right? Tan changes. What can happen here? Cos squared x. One of two things I can do. I can either find an LCM or I can multiply the story in. I'm going to go with multiplying it in. What's 1 times cos x? Sorry? Cos squared x minus sine squared x over cos squared x times cos squared x is equal to what? Sine, nice. What is cos squared x minus sine squared x? Cos 2x. Okay. Let's get on with our lives. Question 4. Bring this again down here. Okay, we have 10 minutes left, so we're going to wrap this up. So if sine 20 is equal to a, express the following terms of a, hint, draw a diagram. Right, so if you got sine of 20 equals a. This is in the first quadrant. For those of you who marked your assignment, that is not drawing a triangle in the first quadrant. No? Please. This way. So there's 20. So sine is opposite over hypotenuse, not adjacent. Hypotenuse. So opposite is going to be a, hypotenuse is 1. Apply Pythagoras, I get the root of 1 minus a squared. Okay. So what is the size of this angle here? 70. Yes. Let's do this. Sine 160. Which quadrant is that in? second quadrant. So it's 180 minus 20. Sign positive or negative in the second quadrant? Positive. So it's positive sine 20. Sine of 20 is opposite of our hypotenuse. So it's a over 1, which is a. Next one. Then 200. Then 200 is which quadrant? 3. How do you get the quadrant 3? Then 180 minus 20. Is there positive or negative? No, plus. Is there positive or negative in the second quadrant, third quadrant? Positive. 10, 20. What does 10 stand for? Opposite of adjacent. So it's going to be a over the square root of 1 minus a squared. Square root, a over the square root of 1 minus a squared. You all understand? Huh?
Yes, sir.
Right. This is a nice one. Okay, all these sums are nice. Bill, what do you see here? 4 sine 10 cos 10. This should remind you of 2 into 2 sine alpha cos alpha. Not so? So, 2 sine alpha cos alpha can be written as what? Sine 2 times alpha. And my alpha angle is 10. Not so? What's 2 times 10? What? Oh, shucks. It's 20. What's sine of 20? 8. Okay. The next one? We got sine of 80. But sine of 80 is nothing to do with sine of 20. Not so? You'd think so, yes, but it has action. We add a special angle. So here, we're going to say sine 60 plus 20 or 20 plus 60. Not so? Remember, it's without this calculator, so it must go into special angles. Okay. So sine expansion, sine alpha plus beta can be written as sine alpha cos beta plus sine beta cos alpha. If I apply that expansion, it's simply going to be sine 60 cos 20 plus sine 20 cos 60. So for the 60-degree triangle, it's 30, 1, 2, root 3. Sine of 60 is root 3 over 2 times cos of 8. Cos of 20 is going to be the square root of 1 minus a squared over 1. Plus sine 20 is a over 1. Cos of 60 is half. So that can be written all as one denominator. That is going to be root 3, root 1 minus a squared. Or it could be written as 1 square root sine with 3 minus 3a squared inside the bracket. It's the same thing. Plus a. Okay. That is 4.7. Did I do the whole of 4 now? No. Okay. So you need a diagram for the even numbers. Okay. I actually should have done the whole of number 4. All that deals with the diagram. But okay, I think I overlooked it. For question 5, it says use the compound double angles to prove that. Use the compound double angles to prove that. So of course the left hand side is more complex. So sine 3x can be written as what? Sine 2x plus x. So sine expansion is going to be sine alpha cos beta plus sine beta cos alpha. You see, it's only sines. So I keep the sines and change the causes. So that day we don't have a choice. We can go into 2 sine alpha cos alpha. Okay, plus, now times cos x, which is this one here, plus, which one of the three am I going to choose for cos? 2x. 1 minus sine squared x. So it's going to be sine x into 1 minus 2 sine squared x. Okay. People, this here is cos times cos is cos squared, so it's 2 sine x cos squared x plus sine x minus 2 sine cube x. Okay. So what we can change is cos 2x. Cos 2x can be written as what? 1 minus sine squared x plus sine x minus 2 sine cube x. Get rid of the brackets here, so it's going to be 2 sine x minus 2 sine cube x plus sine x minus 2 sine cube x. So what do we do now? Like terms. So that's going to give you 3 sine x minus 4 sine cube x. And is that equal to the right hand side? Absolutely. Okay? Five point three. Again, you should agree that the left-hand side is more complex. Okay, so cos 2x can be written as cos 4x, cos 2 into 2x. Not so. Which one of the three cos expansions am I going to use there? The one dealing with cos. Why? There's only coses here. So it's going to become 2 cos squared alpha minus 1. And what's your alpha angle here? 2x. But if you look at this here, what do you notice? That's not what they want. What do they want? They want cos of x. So what must be broken up? Is this part here. Okay, so that's going to give you 2 something squared minus 1. And that black, what's the name enclosed by the black thing? Cos 2x can be written as what? 2 cos squared x minus 1. Why with that one? Because we only have cos x on the right hand side. So let's square that binomial, so it's 2 into. Binomial square is going to give you 4 cos 4x. That times 2 is negative 4 cos squared x. Last term squared is plus 1 minus 1. Multiply out, I get 8 cos 4x minus 8 cos squared x. 2 times 1 is 2 minus 1, which is 8 cos 4x minus 8 cos squared x plus 1, which is also equal to the right hand side. You're going to call it a day here. Okay? Here's the bell also, right? So for homework, please watch this parts of the video that you had the most problems with. If you had a problem with everything, you must watch everything. When you're done with that, please complete all the sums from this exercise that was not completed. We'll discuss this tomorrow. Okay? Sure. People, enjoy the rest of your day. Good morning, good afternoon, class.